How you going, guys? Curtis from Cutting Edge Engineering. So this video is going to be a little bit different. I'm actually going out on site for the week. Unfortunately, Karen can't come with me on this one, and I won't be here in the workshop doing other jobs that we could film. So we actually filmed some content over the Christmas break where we did some servicing on a few of the machines, so we're going to show you that today. But before we get into the video, we've had a very special gift arrive for Homeless. So let's let him open it. Big thank you to the team at Hare Forbes for sending Homeless a lovely bone.
Oh my goodness.
Look at that.
Sit.
What's this?
Good boy. Look, wow.
Get it! Come on!
Yes.
Come on! Come on! Come on! How you going, guys? Curtis from Cutting Edge Engineering. So because we've shut down for Christmas and we're having a bit of a break, we're going to be doing some preventative maintenance on some of the machines, starting with our frontline lathe. What the lathe is, it is a TM-26120G. It is a Taiwanese machine imported by Hare Forbes here in Australia. I've had this for the past 6 years now. It was one of the first things I bought when I launched my business. This lathe has 3.3 meters between centers. It can swing 660 mil and it has a 120 mil spindle bore in it. This machine is equipped with being able to cut metric and imperial threads of all different shapes and sizes, and the spindle speed range is from 12 to 1200 RPM, which is pretty well perfect for all the jobs that we do. So the standard lathe package came with the digital readout, the coolant system, a steady, a following steady, 3 and 4 jaw chucks. It came with everything you needed to start up straight away, and it has basically been trouble free since I've owned it. The only thing I've replaced is the light bulb in the work light and the scale for the y-axis. It got attacked by humidity and it stopped working. Other than that, it has been a brilliant machine. So in the last 6 years, the only modification I have made to this lathe is I changed it from the standard tool post and put the Dorian quick change on it. The main reason I purchased the TM, it is a direct drive. It doesn't have a set of clutches in it. It's not hydraulically driven. I much prefer direct drive over hydraulic because the foot brake actually stops the spindle, where in a lot of hydraulic machines, it stops the motor, but it doesn't actually slow down the spindle. And being a one-man workshop, being able to stop this machine in a hurry is a massive bonus. If I'm anywhere beside the machine and something's going wrong, I can apply the brakes and know it's going to stop. So this may surprise a lot of you, but in 6 years, I have never serviced this machine. I've never topped up any oil. I've never opened up the headstock for any reason. They don't use oil because there's not enough heat getting around in the headstock to burn it off. Where in a hydraulic machine, because they use clutch packs do create heat and they do burn off oil, and you do need to top it up. These machines are a sealed unit, so there is no way debris can get in there unless a bearing is coming apart or something else is going terribly wrong. But a good operator will be able to hear a change in the machine. And I did notice a sound coming out of the lathe. I assumed it was going to be a V-belt. I opened up the back of the machine, I had a look. I wasn't too worried about it, but it has got progressively worse over the last couple of months. One of the V-belts is coming apart. So the first thing we're going to do, we're going to open up the back of the lathe and get rid of that bad belt. So in here we've got all the gears that run the feed box for the machine. That's the feeds and speeds for the carriage as well as the threading. We've also got the 4 V-belts that run from the motor up to the headstock. So I can actually see that 2 of the belts are going to need to be replaced. One of them has a split in it and is ready to break.
Whoa.
And the other one is starting to come apart and has turned itself upside down. But we are going to replace all 4 of them. So I'm just going to take this bottom cover plate off. That'll give me access to the bottom of the belts. So down here we have the main motor that runs the machine. It runs from the base up to the headstock. It also has the brakes attached to the motor. So when you apply the brakes, it stops the motor. Because it's direct drive, it stops everything. Yeah, started to laminate. So if one of these was to actually break and fall down, it might go through the bottom pulley and stretch all the belts, but that's pretty much all that can really happen with it. Everything it'd all basically just fall into the bottom of the machine. So now that the belts are off, I'm going to give it a quick clean out inside, just blow all that belt debris out of the way. I am going to adjust the brakes before I put the new belts on. In case anyone's wondering, that is not oil, that is coolant. It does manage to find its way all around the machines, but there are little catchments that have been cast into the bases in order to catch it so it doesn't wind up on the floor. So we're not trying to restore this lathe, it does get used every day, so it is going to get dirty again. We're just going to give it a quick clean up so we can put it back to work. The way the braking system works on this lathe is it is directly mounted onto the motor, and you have a strap of wear material which goes over the top of that big hub, and that goes down to a shaft that runs along the front of the machine, and the pedals are mounted off that shaft. So when you apply the pressure to the pedals, this little cam comes around and it trips this limit switch, which then cuts power to the motor, and then the brake shoe is applied to the hub, which stops the motor. So we're just going to demonstrate how the braking system works. There are no belts on the machine at the moment, so the spindle is not going to spin. I'm just going to start the lathe up and apply the brakes to show you the limit switch and the brake shoe working at the same time, slowing down the motor. There is still plenty of material on the brake shoe or the strap, but I am just going to adjust them while I'm in here. I don't want to put too much pressure on the shoe because if I do, it will try and stop the motor before it's tripped the limit switch to turn the power off. So we're just going to put a little bit of pressure back on there because I have noticed the brakes are getting a little bit low to the floor when I push the pedal. We'll just make a slight adjustment here and it'll be back to normal again. So the braking system on these, it is extremely basic, but it is very effective and it's a very safe thing to have on a machine. So I'm just going to take the cover off the back of the lathe so I can access the bolts to adjust the height of the motor, which will in turn adjust the tension on the belts. Right, so now that all that's done, we can now install our 4 new belts. So I ended up getting Mason belts, they're a B80, and we got them from our local supplier. So these belts are actually a fraction longer than they're supposed to be, but it's all our supplier had in stock at the moment, and it is so close to Christmas, we're probably not going to get the real ones. But we still have plenty of adjustment left on the motor bracket, so we're just going to wind it down and take up that slack. So while I've got the back of the machine open, I'm going to inspect all of the gears that run the feed box. If there was any damage to that, you would hear it, but quick inspection to make sure the bearings are okay and the gears are in good shape while you're in here. So there's nothing wrong with the gears, there's no chipped teeth, the bearings are all good. So we've done the belts, readjusted the brakes, checked out all the gears, now we can get on to changing the oil. Another way you can tell whether your machine's going to need an oil change or not is you have a sight glass on the side of the headstock and on the feed box. So if there's any material floating around, it generally gets caught in there. And these are perfectly clear, there's no material in them. I do check them quite often. I could probably run this oil for another 6 years without any dramas at all, but I'm going to do an oil change anyway. To do that, I have 2 plugs I need to remove in order to get the oil out of the headstock and the feed box. On this lathe, the oil drain plug is on the face of the headstock. It could have been mounted in the back of the headstock, but it was put on the front. The reason I believe they put it there is so any oil you spill will wind up in the bed and not all over the floor. Why isn't there a spout on it with a tap in order to get the oil out? If you have a look around the machine, the answer is right there. Every fastener is below the surface height, and that is for safety, and it's so things don't get caught on it. You don't want a spout sticking out of there with a tap hanging off it, because you could get caught on it, you could catch an air lead on it, or swarf could grab it while the machine is in motion and tear it off. The manufacturers did the safe thing and they hid all of that stuff below the surface level so it can't get caught on things. Obviously for functionality reasons, you can't do it with everything, like all the handles on the front of the machines, all your feed handles, your little locks for your compound, they can't be below the surface height because they need to be accessed, where the plugs for your headstock, you do them once in a blue moon. That oil is clean. So as you can see there, the oil coming out of the headstock is in pristine condition. It is clean, there's no debris in it, it's not cloudy. You probably could have run that in that headstock for another 5-6 years and had zero trouble with the machine. So this is just Loctite thread sealant, 567. Put a bit of that around the thread just so oil doesn't leak past it. It doesn't dry, so it's not going to lock itself in there.
That work?
Mm-hmm. Righto, so we've got the oil drain from the feed box and the headstock. I'm going to start by putting oil back into the headstock. I do have a little brass cap there I could put the oil through, but I'd like to have a quick look inside, so I'm going to take the lid off the machine. Righto guys, with the lid of the machine taken off it, you can see all the gears inside. So what we have going through the center is the main spindle. The main spindle is controlled via the gears that you select for the speed you are running. So this handle on the front here does your low range and high range, which its selector is in the back of the machine. The next handle along does your RPMs. Its selector is also in the back. And then the other one is also another speed controller. So all of the gearing for your feeds and speeds are on the back side of the headstock. And in the front of the headstock, you have the other two gears. They control your lead screws, so your forwards and reverse, and the speed for your feed rates. And these pipes here, they hook up to the main oil pump, which then distributes oil throughout the headstock. And there is a filter in the bottom of the headstock that is attached to the oil pump. Everything's really clean in there and the filter looks quite good. There doesn't seem to be any discoloration to it. Rather than replace it today, because I don't actually have one here with me at the moment, we're just going to run it the way it is. It'll be fine. So the oil I'm going to be putting in the headstock is ISO 46, which is a hydraulic oil, but that's what the manufacturer specifies goes in the headstock. Righto, so we're just about to fill up the oil in the feed box. You may have noticed when I was draining it, it looks like a very thick oil. I've just rung the supplier of the machine and asked them what oil they specify to go in the feed box. They did say it's the same as what goes in the headstock, which is an ISO 46 hydraulic oil. So all up, we used about 26 litres of oil. I put 20 litres in the headstock and 6 litres in the feed box. All of the oil that we pull out of machinery or we pull out of cylinders, we have a 1,000 litre pod out the back that all the waste oil goes into, and then our waste management company will come and collect that for a fee. So that's the service completed on the headstock. The oil change and everything went well. Doesn't have that weird sound coming from the V-belts. The machine sounds pretty good, the brakes are adjusted nicely, so let's move on to the rest of it. So I'm just going to give the bed a quick tidy up and a wipe down, and then we can go through and oil all of the moving parts. If you are going to use compressed air to blow away loose material, don't concentrate an air blast at your way wipers, because you will end up blowing material under the wipers and you can damage your ground surfaces. So blow away all the loose stuff and wipe clean the rest.
What's that thing?
So that there is the mount and limit switch from the original chuck guard that came on the machine. When it is mounted on there and it is open and you are putting something in it, the machine will not start. Once you close it and take your chuck key out of the way, the machine will work. In my opinion, the guards really don't help you if something goes wrong. They only stop you from leaving the chuck key in the chuck. It's not going to help you or anybody else getting caught in the lathe. It's not going to stop swarf from flying out of the machine when I'm working 2 meters down that way. I chose to remove the chuck guard because the safety around this lathe is 100% my responsibility, and I don't find it very beneficial to actually have it fitted. It's more of an inconvenience for me. So when I'm wiping down the ways, I use a nice clean rag, and as I'm wiping, I'm checking to see if there's any surface damage where something may have impacted the ways and left a bit of a burr, and then I will go back to that area and I will then stone that flat. So I'm cleaning and inspecting for damage. With the bed done, we're going to get onto the carriage. We're also going to remove our quick change tool post, give that a clean up, re-grease it and reassemble it. So on the carriage there is an inbuilt oiling system, and you fill that through the top of the apron. The way the automatic oiling system works is every time you start and stop the machine or go into forward or reverse, it fires a shot of oil through the carriage and it goes down onto the bedways of the lathe. So the oil in the apron, I don't actually change that. It just gets topped up every month or so, depending how much oil you have it dispensing into the bedways, and how often you use it will depend on how often you need to top it up. To adjust how much oil it dispenses, there is a little screw on the bottom of the pump. You wind it in for less or out for more oil. So now we're going to go through and oil all of the moving parts. There are a lot of locations around a lathe that need to be oiled. They are a spring-loaded ball into a brass insert, and what I'm going to be using is Slideway 68 whey oil. So I'm going to use my little pump bottle to put oil into the oilers. By pushing the little ball out of the way, I can then squirt some oil down the inside of the oiler, and when I'm finished, the little ball returns to the top of the insert to stop debris getting down inside. So I'm going to oil the compound slide. You have 2 areas up there that go down to the dovetails, and then you have another 2 ports that then go down and feed the lead screw and the brass nut. After that we'll do the cross slide. Most of the cross slide is fed through the automatic oiling system, but you still need to lubricate the lead screw and the brass nut. We also need to oil the tailstock. There are 3 locations there. 2 of them are what oil up the quill, and the other one is for the lock handle for the quill. And the last thing we need to oil is on the end of the lathe, and it is the block that houses all of the ends of the feed shafts for the lathe. So we've got 3 shafts to go into the end of the block. One of them is for your threading. The other one drives the carriage up and down the machine, and the bottom shaft is for starting and stopping the lathe in forward and reverse using the handle. That is the service completed on the lathe. There is one more thing you would generally do in a service interval, and that is to replace the coolant. I'm not going to be doing that because it is so hot here. It evaporates extremely quickly, so replacing the coolant now would just be a waste. Once everything cools down a little bit and we're not suffering the evaporation, I will change the coolant out for a brand new batch. So the coolant level is quite low, but when we get back from holidays, I'll top it up. With our environment and the humidity at the moment, if you were to leave this uncovered for 3 to 4 days, you would end up with surface rust. So because I'm not going to be using this until next year and we come back to work, I'm just going to spray all of the machine surfaces down with a rust inhibitor to prevent surface rust. Righto guys, so we're back from our Christmas break. We're just about to kick off for the new year, so that what I need to do in order to finish off the service on the lathe is I need to top up the coolant and check the level of the bed. The coolant I'm running here is Hangsteffer's 5030. It is a semi-synthetic coolant and you get pretty good life out of it. So to check the level of the bed, I'm going to be using a MeasureMax precision level. It is good for 0.02 of a mil over 300 mil. So I'm going to set up the level across the bed. I'll be using 1, 2, 3 blocks to elevate the level. You might recognize this piece of lineal rail. It is a perfectly ground surface, and this came from our Toshiba milling machine that we scrapped. And then the level can sit on top of that. And I'm going to check the level of the bed above all of the leveling feet. So the middle position of the lathe does need adjusting, so I'm just going to screw the leveling bolt down to bring the machine back into spec. Now that I've checked those 3 positions, I'm going to go down the bed with the level again, just to make sure it is spot on. Righto guys, so that is the major service completed on our lathe. Apart from 2 of the V-belts being damaged, everything else was in really good shape. I probably didn't need to change the oil in the headstock or the feed box, but we did that anyway. And the machine's not going to need a major service for another couple of years. Because I'm the only one that operates this lathe, I'm very in tune with it, so if there's anything out of the ordinary, I pick up on it pretty quickly. So I do my best to maintain my lathe, but machinery of today isn't built like it used to be. When I purchased this, I knew it wasn't going to be a forever lathe and one day I would have to replace it, but that is just the nature of the industry and being in business. So that's our frontline lathe completely serviced and ready for all the work coming in the new year. Thanks for watching. How you going guys? Curtis from Cutting Edge Engineering. So today's going to be, wait.
Man, how you going guys?
It is a lot like an old brake shoe off a car. Fucking hell, I lost it. fire in a little bit of oil, and then when you, fuck me, fucking hell, fuck, should have said that first. I don't like that.
Yep.
So and then when you, fuck off train. Fuck off train.
That's the one that's, yeah, right. Good thing we're servicing this. Wow. There we go. Well, that was easy.
When you know what you're doing, shit's easy.
What's wrong with that end?
It blew out. That'll blow out. It takes the lid off the machine.
Do you want to put it back on the ground or not? Jesus.
You don't like that sound?
I hate that sound. It like drives me bonkers.
Hang on. I'll help this bit.
I also will help.
Hey. Calm.
Holy moly. Look at that thing. I wonder if he can carry it around. Oh. Dirt. Oh. What's wrong?
Hey, it's you and me.
Let's go.